Hello, this will be a demonstration of proposition 39 from book 7 of Euclid's Elements, which tells us to find the least number which has given parts. We're going to be given three parts, A, B, and C parts. And what we want to find is a number which has A, B, and C parts. We're going to begin by taking the numbers D, E, and F, called by the same name as our given parts A, B, and C respectively. And next we're going to take the least common multiple of D, E, and F. We're going to call that the number G. We can do this by proposition 736, of course. Now the number G having parts called by the same name as D, E, and F. We know this from proposition 737 that if a number measures a number, the measured number will have a part called by the same name as the measuring number. We know that the number G having parts called by the same name as D, E, and F has, therefore, A, B, and C parts because D, E, and F have the same name as the A, B, and C parts. Now next, we want to prove that the number G is the least number which has A, B, and C parts. We're going to prove this by reductio. If it is not the least which has A, B, and C parts, then there will be some number H which is less than G and which also has A, B, and C parts. Now the number H having A, B, and C parts, we know by proposition 738 that the number H will be measured by numbers which have the same name as the parts A, B, and C. That's proposition 738. And D, E, and F, being called by the same name as A, B, and C, are these numbers which measure the number H. So our numbers D, E, and F all measure the number H. Now you'll remember that the number H was made less than the number G, and we've just found that the number H is measured by D, E, and F. That is to say that H is a common multiple of D, E, and F. So if H is less than G, and it's common multiple of D, E, and F, then G can't be the least common multiple of D, E, and F, because there is some number which is less than it, which is also a common multiple. But this is contrary to how we constructed the number G. We made the number G to be the least common multiple of D, E, and F. So what we end up having to say is that the number G is both the least common multiple of D, E, and F, and it's not the least common multiple of D, E, and F, which is just impossible. And so we can conclude that there is no number less than G, that G is the least number which has A, B, and C parts. And this is precisely what we wanted to do. We wanted to find the least number which has A, B, and C parts, and we've just found that in the number G, which means we're done with the proposition Q, E, F. Again, go to my video on 737 if you don't understand this language of having A, B, and C parts, or this language about called by the same name. I'm not going to get into that in this video because I've explained it in 737, so go check that video out. What I will do is I'll just give an example of what this prop is going to look like. Say we want a number which has a 3-part, a 4-part, and a 5-part. Well, what we're going to do is we're going to take those numbers themselves, 3, 4, and 5, and we're going to take their least common multiple. Least common multiple of 3, 4, and 5 should be 60? Should be 60. Yeah, it's 60. It's 60. So 60 will be the least number which has a 3-part, namely 20, a 4-part, namely 15, and a 5-part, namely 12. So that's how this proposition would work. Again, don't worry yourself too much if you don't understand this language about like A, B, and C parts or called by the same name, because it doesn't come up after this proposition. But what does come after this proposition is book 8. This is, in fact, the last proposition of book 7, which is quite exciting. Yeah, this is the end of the first book on number theory, so I'll naturally be moving on to book 8, which is the second book of Euclid's number theory. So I'll see you then in proposition 8.1.